All right, let's look at multiplying radicals. And we're going to start off with a rule, and it is the multiplication property of radicals, or the product rule. And that rule is going to be right here. So what it says is that the square root of the product of A and B is simply equal to the product of the individual square roots of the factors. So what does that look like in real life? What if we had the radical square root 27? The product rule of radicals says that we could break that out into two factors that are also square roots. So the square root of 27 would be equal to the square root of 9 times the square root of 3. And again, the manner in which you write these doesn't really concern me, because commutative property says that you can order your factors in any way without changing your answer. So let's get down to the notes. We're going to have multiplication problems involving radicals that have numbers that are outside the radicals, as well as numbers that are inside, or called radicands. So first of all, if we have numbers that are outside of the radical, we're going to multiply those together. So we're going to multiply numbers that are outside of the radical with each other. We're going to multiply numbers that are inside the radical with each other. And then once we do all that multiplication, we're always going to try to simplify our radical. And when we simplify the radical, that just means, primarily means, to remove any perfect squares from the radicand. And remember, the radicand is just simply the expression that is underneath the radical sign. All right, let's look at the square root of 6 times the square root of 3. My product rule says, yes, I can multiply those two together and just put them under one large radical sign. So the square root of 6 times the square root of 3 would just be the square root of 18. Now that is not in simplified form. So what you need to remember now are your perfect squares. You have to have a really good working memory of perfect squares. So let's write some of those down. Let's see, let's start with 1, 4, 9, 16, 25, 36, 49, 64. I think you know where we're going with the rest. So we should be familiar with our perfect squares up through 25. So what we're looking for is to break up the 18 that's underneath the radical into two factors. And we want to find one of those factors to be a perfect square. So I can look at this list and I see that 9 is a factor of 18. And so is 2. So I can write down the square root of 18 is equal to the square root of 9 times the square root of 2. Okay, so now all I've done is just use the product rule. Now from here I can simplify, and what I like about this is I have a perfect square. I have the square root of 9, so I can simplify the square root of 9. The square root of 9 is 3, but I still have that square root of 2. I can't just forget about him. He stays in the expression. He is going to be multiplied by 3. So that's my final answer, because the square root of 2 is already in simplified or lowest terms. How about number 2, the square root of 10 times the square root of 30? So the product rule says, yes, you can go ahead and multiply those and put them under one big radical sign. So 10 times 30 is 300. Now let's think about two factors of 300, and one of those factors should be a perfect square. Well, I know exactly which one I'm going to pick. I'm going to pick the square root of 100 times the square root of 3. Now, I have a perfect square in 100. So I'm just going to simplify. The square root of 100 is 10 and the square root of 3 is already in simplest or lowest form. Number 3 is our first multiplication example where we have coefficients, or we have numbers that are not under the radical sign. We have the 3 and the 2. So remember, when we multiply and we have numbers that are outside of the radicals, you want to multiply those with each other. So that means the first thing I'm going to do is multiply 3 times 2. Now I'm going to multiply the numbers that are underneath the radicals with each other. So I'm going to draw a big radical sign and put 8 times 5 underneath that. Now I'm just going to go ahead and do the multiplication. 3 times 2 is 6. And under my square root, I'm going to have 8 times 5, which is 40. Now I need to look at 40 and think about factors of 40. A factor of 40 that also has a perfect square. So I can think of one right now, and that would be the square root of 4 times the square root of 10. And don't forget, I still have to bring that 6 down, because that 6 is still have to be multiplied by the radicals. Now I can simplify, because I know that the square root of 4 is 2. So what happens is I bring this 2 out next to the 6. So I get 6 times 2, okay, because the square root of 4 is 2. So I've basically eliminated this. And then I still have the square root of 10, because the square root of 10 is in simplest form. So I don't want to leave it like this. I want to go ahead and simplify the 6 times 2 to equal 12. So we get 12 times the square root of 10. Number 4, again, we have 2 numbers that are outside of the radicals, so we're always going to multiply those together. So that's going to equal 5 times negative 2. And then we have a radical, and we're going to draw a big radical and multiply 18 times 8 and put that product underneath the radical. So 18 times 8 is 144. So let's go ahead and simplify that. 5 times negative 2 is 10. And the square root of 144 is great. It's a perfect square. 144 is a perfect square with an integer root of 12. So my final answer would be negative 10 times 12, or negative 120. And again, here we had a perfect square of 144. All right, let's look at number 5. We have 5x times 2x. Both of those are square roots. So we're going to multiply everything underneath those radicals together and put them under one big radical sign. So we have 5x times 2x. Let's go ahead and multiply the coefficients and the variables together. So we're going to get 5 times 2, or 10, and then x times x, which is x to the second power. Now, 10x squared. Let's break that into 2 factors. Let's say that's 10 times the square root of x squared. So we have the square root of 10 times the square root of x squared. So all we did here was just use our product rule. Now, the square root of 10 is already simplified because there is no factor that is a perfect square of 10. So now we have the x squared. Let's look for a minute what x squared looks like in expanded form. X squared is going to look like x times x underneath the radical. So we know that if we square a number and then we take the square root of the number, we basically cancel both operations out. So what I'm looking to do is pair up these x's underneath the radical sign. Once I have paired them up, I can remove them from under the radical sign and put one of them outside the radical sign. So my final answer would be x times the square root of 10. Okay, because I had a pair of x's which was equal to my x squared, and I know that the root of a squared number is just the number. All right, so that answers x to the x times the square root of 10. Number 6, we have numbers underneath the radical, no numbers outside the radical. So we're just going to create one big radical sign and multiply everything together. 15 times 10 is 150, and x to the second times x to the second is x to the fourth power. So let's break this down into two factors, the square root of 150 times the square root of x to the fourth. Now, what is a factor of 150 that's also a perfect square? Well, I know that 25 times 6 equals 150. 25 is a perfect square. So I am happy with this choice because I know I can simplify that to an integer. But what about the square root of x to the fourth? Again, because we're taking the square root, we're going to be looking for pairs. And we're going to eliminate the pairs from underneath the radical sign and put the roots out to the left of the radical sign or outside the radical sign. In this case, what we have is the square root of x times x times x times x. I'm going to pair these x's off, so I have one pair, I have one pair of x's, two pair of x's. So I can eliminate those from being underneath the radical sign and move two x's outside the radical sign. So I would have something that looks like this, x times x. So let's go ahead and simplify. The square root of 25 is just 5. And then I have my two x's, x times x, or x squared, and then I still have my square root of 6. So my answer is 5x times the square root of 6. Okay, number 7, we have the square root of 8x squared times 4x. So let's go ahead and multiply those all underneath one big radical to get 32, x to the third. 32 does have a perfect square that's a factor, and I know that the square root of 16 times the square root of 2 is equivalent to the square root of 32. Then I have x to the third. So let's draw this out in expanded form again with 3 x's underneath the radical. Remember, I want to put these in pairs, and if I find a pair, I can cross them out from being underneath the radical and then move that x outside of the radical. So I was able to move one root out, but I still have this little x left over, this x to the first left over. He is going to have to stay underneath a radical. So let's simplify. The square root of 16 is 4. Then I have x pulled out from underneath my radical. And then I have a radical with 2 and x underneath. So my answer would be 4x times the square root of 2x. Number 8, again, this is all multiplication underneath the radical, so let's just draw one big radical sign. Oops. This is too big. Okay, whoops. So 3 times 18 is 54. A squared times a squared is a to the fourth. And then we just have this b to the first all by himself. So 54 breaks into two factors, the square root of 9 and the square root of 6. So I have found a perfect square common factor, which is negative 9. Which is the square root of 9, sorry. So I'm eventually going to pull that root out from the square root of 9 and make that a 3. Now I have a to the fourth, so let's go ahead and do a shortcut. Instead of writing out a to the fourth underneath a radical sign in expanded exponential form, let's just take a shortcut. Let's look at the exponent 4, and let's just divide that by 2, a to the second power. So my root would be a to the second power. Now b still has to stay underneath the radical because he isn't paired off with anybody. He's still on his own. So let's go through this list and just simplify. The square root of 9 is 3. We have a squared. Now underneath the radical I have 6 and b. So my answer would be 3a squared times the square root of 6b. So you notice when I get ready to simplify this and put down a final answer, I'm going to go ahead and write the numbers that are outside the radical first, and then save the numbers that are inside the radical to write last. Number 9 Again, I'm just going to multiply everything under a big radical sign. 5 times 10 is 50. A times A is A squared, and B times B squared is B to the third. All right, remember when I simplify, I'm going to look for common factors that contain a perfect square. So I know that if I multiply 25 times 2, that's equal to 50, and 25 is a nice perfect square. So I know this is going to simplify to 5. We're going to still have our square root of 2. Now, a to the second power, remember we can divide that exponent since it is even. I can divide it in half and take my root out from underneath the radical sign and just make that times a to the first. B to the third, I'm going to have 3 b's. Okay, so that means I have one pair of b's. With that one pair of b's, I can pull one of those b's out and put it outside of the radical, but that's going to leave me with one b that still resides under the radical. So let's go ahead and write our final answer. Remember, I'm going to go ahead and get all of the values that are not under the radical together first. So that's going to leave me with 5ab times the square root of 2b. Okay, the last one is a big one. We have numbers that are underneath the radicals. So let's multiply 98 and 5, and we get 490. A to the third times a to the seventh is just a to the 10th. B to the third times b to the first is b to the fourth. So I'm happy to see that I have an even number of exponents that I'm taking the square root of. So now I know that I'm not going to have anything underneath. I'm not going to have either a or b left over underneath the radical sign. So for 490, my two factors that I'm thinking of that would work the best would be 49 and 10. Because the square root of 49 is 7. 49 is a perfect square. So let's continue on. We have a to the 10th. So we're just going to divide that exponent 10 by 2 and come up with our root of a to the 5th power. B to the 4th, we're going to divide our exponent by 2 and come up with b to the 2nd. And again, that will be our root. Now we can simplify. 7 times the square root of 10 times a to the 5th b squared. Now when I write this all together, I'm going to pull out all of the values that are not underneath the radical sign and get 7a to the 5th b squared, and then add in my square root of 10. And that is my final answer. Thanks for listening.